In this lesson, we're going to talk about equations and give you an introduction into algebraic equations. But before that, we need to talk about the difference between an algebraic expression, which is what we dealt with in the last video, and an algebraic equation. Now, if you recall, with an algebraic expression, we had sum and differences of terms, and we did not have an equal sign. So we would have terms added together or terms subtracted, but there was not an equal sign in an algebraic expression. And what we do with algebraic expressions is that we simplify them. We combine like terms, we might use distributive property, but we simplify the algebraic expression. In an algebraic equation, we will have an equal sign. And our algebraic equation says that two algebraic expressions are equal to each other. So you're going to have two algebraic expressions separated by an equal. So you will have an equal sign. And what we do with an algebraic equation is that we solve. We solve the equation. We find the values for the variables that will make the equation true. So when an equation contains a variable, the equation may be true for some values of the variable and false for others. And each value of the variable that makes an equation true, we call that the solution of the equation. And we say we solve the equation. So solving an equation means find all of the solutions. So let's look at our first equation. Notice we have x minus 25 equals to 0. So two algebraic expressions separated by an equal sign. So we're going to solve for x. That means find the value of x that will make this equation true. And you're going to hear me talk about isolating the variable. So we're going to try to isolate x. We're going to use the addition property of equality, and that says that you can add the same number to both sides of an equation and you will have an equivalent equation. So that's a legal move, to add the same number to both sides of the equation. We're going to add a positive 25 because that's going to help us to isolate x on the left side of the equation. So here we have x, and then when I add a negative 25 and a positive 25, we get a 0. And then 0 plus 25 is 25. So let's check our solution for x, and that means substitute 25 in where x was in the original equation, and we get 25 minus 25 equals 0, and that's true. So our solution checks. Okay, so here's problem number 2. Again, we want to isolate z, so we're going to add the opposite. We're going to add a positive 19 to both sides. Negative 19 plus 19 is 0, and then we have a negative 12 plus 19 on the right, and that's going to be a positive 7. And we're going to check that by substituting the positive 7 in for z in the original equation. 7 minus 19, well, as you know, that is negative 12. So our solution checks. Okay, this equation has fractions in it, but don't let that scare you. We do the same thing. We need to isolate z. We're going to add a negative 3/4. So we're adding the opposite of positive 3/4. We add negative 3/4 to both sides of the equation. And that's because we want to get a 0 on the left so that we're left with just z. And whatever we do to one side of the equation by the addition property of equality, we must do to the other. Okay? So here we get z. Now, you know we're adding fractions, so we're going to need a common denominator. And the common denominator between 2 and 4 is 4. So we're going to change these. Of course, down here we already have the right denominator. But in the top fraction, we need to multiply top and bottom by 2 to get our denominator. Now, as you recall, we're going to work with the numerators with just the tops, and when we add a negative 2 and a negative 3 together, we keep the sign and add the numbers, so we get negative 5. Keep the denominator, so our answer is negative 5/4. Okay, we've got a different problem here this time. This time we have 10 times a equals negative 70. 10 times what number equals negative 70? You can probably do that one in your head, but let me show you a neat little rule that multiplying or dividing both sides of an equation by the same number gives us an equivalent equation. So here we're going to divide both sides by 10 so that we can isolate our a, and negative 70 divided by 10 is negative 7. Easy to check. Substitute in negative 7 for a. 10 times negative 7 is negative 70, so that works. Next equation, fractions again. We have 3/8 equals 1/4 times y. Now rather than dividing by 1/4 to get that y by itself, we'd like to be able to multiply both sides by something that's going to get us a 1y here, and that will be the reciprocal of 1/4, which is 4/1. So let me rewrite this here, give us some room. So we're going to use the reciprocal of 1/4, which is 4/1, and we're going to multiply both sides of the equation by that 4/1. Notice how on the right-hand side, these 4's cancel and give us a 1y, and that's what we wanted. We wanted y by itself on one side of the equal sign. And over here, when we multiply these fractions, we can do a little reducing first and then multiply across. And so we get 3/2 equals y. We'll do a quick check here. Substitute in 3/2 for y. Let's see what 1/4 times 3/2 is. Well, multiply across and we get 1 times 3 is 3, 4 times 2 is 8, or 3/8.